as I mentioned, most of you are probably aware that QSC is an amplifier manufacturer. We've been for a long time. Historically, we've created, Class A, Class AB, Class H amplifiers, and probably 10 years ago, we introduced our first Class D amplifier. That was the PL3. I'm going to be talking primarily about our newest amplifiers, which are the PLD and CXD amplifiers, and then a little bit later, the CXD-Q amplifiers. These are all Class D amplifiers. But they're actually pretty unique in that we've added a number of pieces of technology to them. The platform, when we create amplifiers, it's actually a very expensive and takes a long time. So my background, I spent 10 years at Harman developing signal processors. I worked for DBX and BSS. Signal processors, especially if it's a known platform, you can create a new product in about 6 to 9 months. Amplifiers take years to develop because, as it turns out, high voltage kills people. And so there's a bunch of regulatory stuff you've got to do to develop those. And the technology is a lot more tricky. With a signal processor, you make the circuit, and if it doesn't work out right, well, you make some adjustments to it. Amplifiers, you make the circuit, and to test it, you blow things up, and so that's been a fun learning process for me to learn about that. So when we do develop a product, we tend to make a platform that we can use for multiple products. And so that's what we've done with the PLD platform, the PLD, CXD, and the CXDQ that I'll talk about. The PLD, CXD, and CXDQ, there's 3 amplifiers in each of those families. There's a 4.2, a 4.3, and a 4.5. And those numbers stand for the number of channels, 4, and then the 0.2, 0.3, and 0.5, that's the amount of continuous watts. So the PLD 4.2 provides 2,000 continuous watts, and actually more than 2,000 watts in terms of burst or music power, dynamic power. The 4.3 is actually 5,000 watts of dynamic or music power and about 3,000 watts of continuous. And then the 4.5 is 5,000 watts continuous, 8,000 watts dynamic or music power. And the same thing with CXD and CXDQ. And so I'm going to talk about some of the pieces of technology that went into these amplifier products. There's actually more things beyond these 4 main technology groups, but I'm going to talk about 4 main pieces. So the first one is what we call FAST, or Flexible Amplifier Summing Technology. And this is a new technology that we've developed to help create a more flexible and usable product. What flexible amplifier summing technology is, it allows us to take the 4 amplifier channels in these PLD and CXD amplifiers and combine them. Now, traditionally, most amplifiers, you can bridge channels. So let me get into my little, so here we go. So, and these channels can be combined so you can have a 4-channel amp or a 3-channel amp where you combine 2 channels together. Now, you can bridge those, but you can also do something like paralleling. Paralleling, it's not unlike if each of these amp channels was a battery. You're all familiar with batteries. You take 2 batteries, you put them end to end, you've doubled the voltage across both of those, right? Everybody's done that, everybody's seen that. You put 2 batteries in parallel, you've doubled the current. And so these amplifier channels work in the same way. Historically, it's been difficult to combine channels in parallel with amplifiers because the channels will tend to fight against each other when you combine them in parallel. And we have found a way around that using Class D technology. So you can have a 4-channel amp or a 3-channel amp, and you can combine those 2 channels together, either in parallel or bridging. You can also combine 3 channels together. You can only do that in parallel. You can't put all 3 in series. Or you can do the Spock signal there. So 2 channels here, 2 channels here, and this could be bridged, this could be parallel, vice versa, however. And then you can combine all 4 channels together to make a monoblock. And so that makes for a very flexible package. It means that one amplifier can be used one day for 4 monitors, and the very next day you can combine all 4 channels for a massive subwoofer or whatever. So how does it work? Every amplifier, and I'll refer to some of these graphics here. I hope everybody can see those. Every amplifier has the same type of curve. So what we have here is power on your vertical and impedance on the horizontal. And the the output of the amplifier devices is bounded by the current limitations and the voltage limitations. And so current is linear, voltage is not. And so what happens when you bridge channels is you get more voltage. Remember, you're putting those two batteries end to end, so you're doubling the voltage. You get more voltage, but only in the upper impedances. You still have that current limitation that the output device is capable of. So that's what happens when you bridge those two channels. When you parallel, you get more current. And that is really useful, especially in the lower impedances. And so that's something that is new and unique about these amplifiers. And in fact, so that's two channels in parallel. You can combine 3 and even 4 channels in parallel. And so that gives you a lot more power in the low impedances. Another thing that's unique is you can take 2 channels in parallel and another 2 channels in parallel and then bridge those together. And when you do that, you get a massive amount of power. And the thing that's really cool is that's in that useful 4 to 8, 4 to 12 ohm region where a lot of loudspeakers actually, I mean, that's your average loudspeaker is an 8 ohm loudspeaker. And so you can combine all of this power together and drive just, provide a massive amount of power, massive amount of dynamic power for those loudspeakers. Now remember, any sort of power amplifier is still bounded by the other things upstream. So your AC input, your power supply, the power reserve. But essentially, that's the way these amplifiers work, is by combining channels, you get some flexibility that you wouldn't have normally, and you also get more power depending on the impedance that you're driving. So it's a very, pardon the pun, it's a very powerful tool. Yeah, so this might be the limitation. So this would be a 5,000 watts continuous power. But remember, if you have a large power reserve, lots of capacitors in there, you get dynamic power that's greater than that 5,000 watts. You can easily get 8,000 watts of dynamic music power out of these amplifiers when you're just listening to just a music content as opposed to a sine wave. So it enables these amplifiers to be very, very flexible for different applications. The other piece of one of the other pieces of technology that we put in the PLD and CXD amplifiers is DSP. Now, obviously, we're probably the last amplifier manufacturer to bring, amplifiers to market with DSP. Why is DSP in an amplifier useful? Well, essentially, the amplifier is hooked up to a loudspeaker, and you want to put in the processing for those loudspeakers. And so you have all of that processing available in the PLD and CXD amplifiers. The advantage of combining signal processing in an amplifier is that you can then better manage the amplifier itself. So not only are you providing processing for the loudspeaker, but you can also maintain the amplifier. And if you're running into a limitation, whether it's thermal or whether it's current or whatever, the signal processing in the amplifier can actually compensate for that. And so it can start cranking down on your signal, use limiting or whatever other tools to help manage that system, because now it's not just the loudspeaker, now it's the loudspeaker and amplifier together, and the DSP can optimize that system. Additionally, so we talked about speaker processing. With QSC loudspeakers, because we know exactly what those speakers are and what they need, we use something that we call intrinsic correction. And basically, it's fancy signal processing based on a number of measurements that we've taken with our loudspeakers. And so, it's over 70 different measurements that we use with our loudspeakers. Power response and frequency response and all of these different things. And we create a set of FIR and IIR filtering and dynamic processing that we can then use to manage those loudspeakers and optimize them so that they perform to their very best. Other technology that we've put into the PLD and CXD amplifiers includes some amplifier technology. We created our own output MOSFETs. This is one of the reasons that we can do this channel combining, is these MOSFETs, we've got 6 different pieces of amplifier technology in there combined into a single MOSFET, a single output device. And it allows us to not only do this channel combining, but it also allows us to manage this package better in terms of thermal performance and signal processing. It's just lower noise, higher output, and at a lower or higher thermal performance, lower temperatures. As we developed the amps, we of course did thermal modeling, and then we did some interesting things on the power supply, not on the power supplies, on the heat sinks. We've got 4 channels, and because of that, we can combine these channels, and then as we apply connect the channels to the heat sinks, we can apply them across. So when you combine channels, typically it's going to be A and B. Well, those are on 2 different heat sinks, and so you get better thermal performance by doing that, by sharing the load across multiple heat sinks. We also added power factor correction. Now, I'm not sure if you're familiar with power factor correction, but essentially, the way you draw power from the wall, typically with an AC rectified design, an older amplifier design, is you're only actually taking power from the wall when the AC voltage reaches its peak. Going to the diagrams here, typically with an AC rectified design, you're only getting power when you're at the peak of that AC voltage, and the rest of the time, it's actually sitting idle. With power factor correction, you can actually match the power draw from the wall with the AC waveform, and so you're actually drawing power throughout the entire waveform. It means, number one, that you can lower your AC requirement because you build up your power in an amplifier is like a storage tank, and it's like you got a storage tank on a hill and you pump water into it, right? And with an AC rectified design, you could only pump water when your pressure is high enough, and so you'd shoot water in, but it's like it's squirting it in in this case, every 60 hertz. With an AC rectified design, you're always putting water into that tank, so you're building up a better power reserve without needing as much AC pressure. Essentially, what it means is you can get away with a lower AC supply. And so it's just another tool to make these amplifiers efficient. Finally, we've got a universal power supply. Probably doesn't matter too much for you, except for it does make it if you're running amplifiers off of a generator, for example, or actually with it also helps in terms of lightning spikes and things like that, where the power can be spotty. The universal power supply helps to manage that and just makes the AC input more usable for the amplifier. We've also got, because we've got DSP in the amplifier, we can manage how the amplifier uses that. And so if there's no AC input signal for more than 15 minutes, the amplifier output stage will actually shut down. And so you're better managing that AC draw, and you're taking less power from the wall because you're shut down part of that. Now, as soon as you've got input signal, it powers the outputs up, and it's totally seamless. You never hear it, but it means that we're drawing less power. It just makes for, again, a more efficient design, more efficient amplifier. The final piece of technology that we put into this was we spent a lot of time developing a user interface, user experience. And what we did is we actually got outside experts, user interface design experts from outside the audio industry. And these guys were actually appalled. We took them to the NAMM show and walked them around, showed them some different products from some competitors, some of our own products, showed them some computer applications, and they were appalled by the products that are in the audio industry. And they said a lot of these products are designed with an older philosophy in mind, and these guys design computer products, like they designed microwave ovens and washing machines and websites, and so they're real user interface design experts, and they helped us come up with a user interface design to maximize the usability of the amplifier. So I'm sure all of you have used amplifiers with DSP before, and most of them you cannot access all the different parameters from the front panel. In the case of the PLD and CXD, you can. And certainly there's times when you want to lock that away, and in the PLD and CXD you can lock it away. But if you need to access, if you don't have your laptop or whatever, if you need to access those parameters from the front panel, you certainly can in the PLD and CXD. I talked about the flexible amplifier summing and how it provides different power at different impedances. Well, that can be quite confusing at times. And this is a chart of the actual continuous power that you can get from various channel combinations, 8 ohms, 4 ohms, and 2 ohms. And you can see it can be confusing. It's like, how much do I use? What channel configuration do I use based on that? Part of the user experience is we developed a configuration wizard that helps the user, helps you get the most out of the amplifier. So essentially, you select the impedance that you want to drive. You tell it how many watts you want that output to provide, and based on that, it'll automatically give you a suggestion on the channel combining configuration. So it makes something that could be confusing a lot more usable. And so based on this wizard application, it helps you choose the configuration, and then from there you can actually select loudspeakers. Of course we put all the QSC loudspeakers, their processing in there, but we also took excuse me, about 70 competitors' products, and when, if available, we got their loudspeaker tunings and put them in the PLD and CXD amplifiers. So you can actually use other products, just pull them up from the menu, load that speaker into output A or output C, and then use this other subwoofer from competitor XYZ and put that into output A, whatever. And based on that, you can, it's quite easy to create a preset. So those are the 4 key elements of the PLD and CXD amplifiers. Now, so just to kind of refresh, so we've got the flexible channel combining, the DSP, of course. We've got the advanced amplifier technology with our own custom MOSFETs, the power factor correction, and then the user experience. Now, looking at the 2 different models, what's the difference between the PLD and CXD then? To shorten it up and to make it easy, it's really primarily connectors. On the PLD, which is designed for production and live sound, we've got XLRs, NL4s. You can see even on the PLD 4.5, it's still only 21 pounds, so it's still a very, very lightweight amplifier. The CXD, designed to provide some of the features that are more for integration. So life safety compliant, 70 and 100 volt direct drive. If you want to, you can load a custom logo on the front panel using the software. Front panel lockout, actually that's available on both the PLD and CXD. We've got GPIO, Phoenix or Euroblock connectors for the inputs and outputs, so you can just do blunt cut rather than XLRs or NL4s. So really designed to try to optimize the experience for each of those product groups, categories. So before I move on to the CXD-Q, which are our QSYS amplifiers based on the CXD platform, any questions about the PLD or CXD amps at this point? Yeah? I just want to clarify. So do the CXD provide 70 and 100 volt direct drive? Yes, they do. So I've got 3 amps in the family. I've got the 4.2, the 4.3, and the 4.5. The 4.3 and the 4.5, 70, 100 volt direct drive on all 4 channels. On the 4.2, you actually need to bridge 2 channels together if you want 70 or 100 volt direct drive, but certainly they do. Yes, they all provide that capability. It's just in all of them do provide direct drive. The 4.3 and the 4. 140 volt is available on the 4.3 and the 4.5 only. Yes, that's a great question. Yes. Any other questions? Okay, I'm going to move on to the CXDQ amplifiers. And essentially, this is a QSYS version of the CXD amplifiers. But because it's designed to work with QSYS, there are some things that are a little bit different. So the same kind of power as in fact, it's the exact same power board that's used in the CXD or the CXDQ. So it's still a 4x700 watt, and this is that's dynamic power, or 4x500 watts continuous power, or 4 by 1400 watts, or 4 by 2000 watts. That's all into 4 ohms. We've got the 70 volt and 100 volt capability, so that is all the same, CXD and CXDQ. Same power platform. We've got the same flexible amplifier summing technology. In the case of the CXDQ, you select it in your QSys design. And so it's really designed to work together seamlessly. Differences, I've got a QLAN network port on the CXDQ. This is a redundant layer 3 Ethernet connection, and it just makes for very seamless and easy integration. You just connect it to the switch and set it up in QSys, and it just goes. The inputs are microphone and line inputs with 48 volt phantom power, and they're different. The design of the amplifier is different in that the inputs of the amplifier don't necessarily go to the outputs. They actually go into, if I was to create a design on a piece of paper, I would say, here's the inputs, they go into the core or into the network, and then here's the outputs. They come from the network, they come from the core. And so they don't necessarily need to be connected. And so that's why we put mic line inputs, because these could be used for something completely different than the outputs of the amplifier. Or actually, you guys are, from your point of view, inputs to outputs, left to right. More about that in a minute. Euro or Phoenix speaker connections, pretty straightforward. Also GPIO. On these amplifiers, we've got 8 GPIO ports, and they provide complete GPIO integration from QSys. Our cinema guys are actually quite excited about this because they're going to use these amplifiers, and in cinema applications, you've got a lot of other things like the skirts that they use to mask off the projectors. You know, once you go into a movie, you watch all the previews, and then they mask the screen, and now you've got just the size of the screen. So they're going to use the GPIO ports to drive all those little motors. When you add an amplifier in the QSys design, it's as simple as going into the inventory and selecting Add, and then you select which amplifiers you want. Very, very easy and straightforward. The CXDQ amplifiers, like any other amplifier in QSys, any other QSC amplifier in QSys, they provide full control and monitoring of the amplifier. And so it gives you inputs, it gives you outputs, it gives you, you know, if there's any clip, if there's, it just shows, it gives you all the measurement detail, all the information about that amplifier, the temperature, and so forth. Everything's there and available. Like I said, the inputs are mic line inputs with phantom power, and they are separate. And so when you bring this amplifier into QSys, in fact, my next slide, yes. When you bring the amplifier into QSys, your inputs and your outputs are separate. So here's 4 mic line inputs. They're going into a mixer from amplifier 1. I've configured amplifier 1 as a 3-channel amplifier. And so I've bridged 2 channels together, and then I've got channels C and D here. They're feeding those 3 speakers. I've got amplifier 2 here, and these are going into a mixer. So these are just mic line inputs going to a mixer, feeding that. The inputs for amplifier 2 are coming straight from this audio file player. That's just playing an audio track, which it's what we'll use later for speaker demos. And so you can see how the inputs do not need to be connected to the outputs in the design, and it makes it very, very flexible. I could bring mics into the amplifier and use them for a system that's completely different than what the outputs are driving. So it's a very, I think, powerful tool. That was a lot of information in a short period of time. Any questions about PLD, CXD, or CXDQ amplifiers? So I have either done such a great job, or you guys are just awesome students, and I think it's the latter. Thank you very much. I'm going to turn the time over to Travis.